Standard vector. When you don't know which container to use standard vector. Vector is basically the workhorse of all of C++ template library. It is the default to use and it's so widespread that you have to know the details. Hi everyone, I decided to explain the complete STL. Over this course we will start from the ground up and cover the complete standard template library. If this is interesting you, stay tuned and subscribe. Today we will cover vector, so let's start. Declaring a vector is pretty straightforward. The first thing that we need to do is to include the library or the header file of vector, which is called vector, and then we can declare any vector by using standard vector and then the type of whatever we want to store, for instance integer, and then we need to give it a name and are already done. When it comes to adding new elements to vector, you usually have two different methods to do it, which is using either pushback or mplaceback, or using insert to insert a specific element at a specific position. So the first option here is pushback, and pushback will just enter the element at the end of the vector. So because the vector currently is empty, it means that after we have pushed back now a 2 into this vector, the vector will have one single element, which is 2. And if I copy this line and do the same again, it will have the elements 2 and 3. And we can just verify that by outputting it to our console using here the ice cream library and just saying that I want to output my vector to console. So let's switch to the console and see the result. So we go to the console and we compile the program and let it run. And we see that the vector has the elements 2 and 3 at their respective positions. If I now want to insert an element at a specific position of vector, I can use insert, and for that I can use an iterator. So I say that auto iterator equals my vector dot begin, and now I can use this iterator to insert something into the vector. For instance, directly at the begin of the vector, I can say my vector dot insert, and here we see if we use autocomplete that it suggests us an iterator, and I need now also the value that I want to insert, for instance a 4, and now it will insert the 4 at the position where this iterator currently is. If we compile this program, we will now see that because the iterator was pointing to the begin of the vector, that if we also output the result, we will see that the first element of vector now is a 4. And here we see that at this position it was 2 and 3, and then we pointed to the begin and we have now 4, 2 and 3. So a few words to mplaceback. I have prepared here a small example which demonstrates what mplaceback does. Usually people think that somehow mplaceback is a silver bullet and will magically make your code faster by avoiding some copies or some move semantics or whatever, because somehow it was also introduced in C++ 11 and people confuse it with the move semantics. So let's have a small look at what it actually does. We're having here a class which is called dummy, and we construct the vector out of this class dummy. And we see dummy has nothing else than just a value which is being stored in inside the class, and during the construction of dummy this value is passed. And now we have basically two options to get something into the vector. If we use pushback, we need to use a complete object which has already been constructed. So what will happen here in this case is that a temporary object dummy will be created, and this temporary object dummy will then afterwards be used to put it inside the vector using probably a move, because it's just an R value reference. So because there's no real object here but just an R value. And basically this is already as fast as it gets. So you cannot make this code any faster by using mplaceback. The only thing that you can do by using mplaceback is avoid a little bit of writing and use the appropriate constructor. So the same thing with emplaceback would look something like this, because emplaceback already uses the correct constructor. So it will use here the correct constructor call to dummy, and we don't need to construct dummy ourselves. However, from a timing perspective, both of them will yield probably exactly the same code. And if I now use something like this, it will definitely result in the same code. So emplaceback usually does the same as pushback, and only if you're very sure in what you want to write, you should use emplaceback if you are really relying here on a specific constructor call that you want to have. So when in doubt, always use pushback as default, because it's already pretty fast and the gains by emplaceback are not that huge. So of course, usually, I mean, there are special cases where this might not be the case. But let's get back to our first example. What we want to do is now access the elements of the vector, and there are 5 methods to do that. So we have my vector, and I can either go with the brackets operator and, for instance, access the first element of the vector, or the element at position 1. I think it's not the first one. And then we have 5 different methods. So the second method would be to use the add function, and I can also use now the position which I want to access. Then I have front and back. Front and back are basically accessing the first and the last element of the vector and are pretty fast. And the last possibility is to access the data pointer directly by using data. This will return a pointer to the underlying data object, so we still need to dereference that one. And now this one will point to the very first element that is stored in the vector, because it's pointing at the direct vector, so we could even use some pointer magic to access some other different elements. So let's compile this code and see what's happening. And we should see 4 times the first element and 2 times the first element, then the front element, the back element, and the data element. So we see here 2, which is the element at position 1, 2 element at position 1, 4 is the first element, back 3 is the last element, and here this one is the first element again. So in total, 5 different methods to access whatever is stored in vector. Now let's remove elements. Removing elements can be done by erasing or by popback. So we can use my vector dot popback, and this will remove the last element that is currently stored in the vector. Or we can again use an iterator to delete the specific element. So we can point a second iterator to the beginning of the vector and then use erase to erase whatever element is stored at this position. And if we output the vector afterwards, we will see that there is just 1 element left in the vector. So let's compile and verify that this actually happens. So we compile the program, and we see that we had at the beginning 3 elements, and after we have popped back the last element and deleted the first element, we are left with the middle element, which was a 2 and works as expected. Since vector has dynamically allocated memory or a dynamic size, size management with vectors is actually quite important. So there are a few methods to access the size and what is currently allocated for the vector, and also its capacity. So the important functions here are my vector.size. This returns what the size of the current vector is. So how many elements are currently stored in my vector. And then there is the capacity. So the capacity will give us how much or how many elements could be stored in the vector. And as long as we're just adding elements inside of the capacity of the vector, no reallocation of memory needs to be done as the element is added. If we add an element, if the capacity of the vector is exceeded, this means that the complete memory needs to be reallocated, and this adding of the element will be quite computational extensive because of all the move operations that will happen in that space. So it's really important that the capacity and the size of a vector are different things. If resizing of the vector doesn't happen automatically because you're adding a new element, there are 3 methods to resize your vector. The first one is my vector dot shrink to fit, and it does exactly what the name suggests. So it means that if the capacity is much larger than the current size of the vector, it shrinks the capacity and deallocates the memory that was taken up by the vector. So all the elements that are currently inside size still fit into the vector, but the vector itself gets a little bit smaller. The next one is just resize, and this one will resize the vector to the exact amount of elements that you pass as an argument. So you can specify that it needs to be exactly this size. But be careful, since this is really resizing your vector, it means that if you have stored more elements than you want to resize to, those elements will be lost. The last method, and this one is quite important, is reserve. And it is so underused in C++, and much of the code that I see could benefit from reserving the right vector size. Usually, you know in advance how big your vector will eventually be. So it does make sense to tell the program exactly that, to tell the program how much space you will end up taking up. So for instance, if you're doing a big for loop, and iterating over the vector and iterating over thousands of elements and adding them to the vector inside of this loop, you will at the beginning already know how big your vector will be at the end. In this case, it makes sense to reserve the memory up front, because then the resizing operation that would need to be done during adding the new elements will not be done, and your code will be a little bit faster than without reserving the memory up front. So this is really important, and I see so many people not doing it and wasting a little bit of computation power on that. So yeah, what is the reason to use a vector? So vector basically is a dynamically allocated array, which means that it always has the right size and can fit all the data that you need to fit. So it grows as you need it to grow. However, since this is the case that it grows dynamically, it also means that the memory gets allocated dynamically, which means that adding new elements will be quite fast until you reach the limit of the vector and until your program needs to deallocate and allocate a completely new memory space for that vector. So it's very important for vector that you reserve the right amount of memory at the beginning if you want to save some time. Other than that, it's pretty much the go-to container for any of the programs, so if in doubt, always use vector. That's all from me today. Get the code from GitHub and start your machine and start coding. And as always, enjoy coding.